Welcome back. So far, in the discussions of superposition and the resulting equations, etc., and the explanations that we had, they were for we did not encounter in that any boundaries, if at all. So our pulse was moving left to right or right to left, wave was moving left to right, right to left, whatever, and we got the things. Now, what happens if the pulse or the wave meets a boundary? And if the boundary is rigid, then reflection results. Reflection also results if the boundary is not rigid. But one of the examples is that of echo. If you call, make a sound in the mountainous regions, then the sound that you have made, it returns back after some time from all sides of the valley. In the valley, you are in the valley and you have made a sound. Maybe you say Ali, and after some time the sound will come. Ali, 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 and it will die out after some time. So that is what happens in the case of echo. The echo derives the name from that of a goddess, a Greek goddess, who, if you say something, if you utter a syllable, for example, you call Sita, then she will utter only ta, 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 the last syllable. That was the beauty of the goddess, and her name was Echo. Well, anyway, if the interface between the two distinct media exists, then there is a little bit of complication. And normally we say that in the case of oblique incidence, okay, when it is not straight onto a surface which is a rigid body, and there is an interface between two distinct media, one is rarer, the other is denser, or the first one in which it is traveling is denser and the other one is rarer, and this is the boundary which separates the two media. Rarer means that the density is less of matter and the velocity is more. Denser means the density is more but the velocity is less. Well, in oblique incidence, the transmitted signal is said to undergo what is called refraction. There can be a partial reflection and a partial refraction, and those things are possible. It all depends upon what is the nature of the interface and what are the natures of the two media where this is taking place. Now, I will try to explain to you as to what is happening. I'm not going to draw so many things. I take you as an intelligent person. So let us see that there is a pulse, okay, and it travels to a rigid body. When it reaches here, because all along this information is transmitted to every constituent of this elastic body, which is a stretched string. with the tension T, and it has got the uniform mass per unit length equal to mu. So that the velocity is equal to under root tension upon the mass per unit length. Okay. So what it says, I will say it in both English and in Urdu. When it reaches here, there is an information which is transferred to each coming particle on this string, and the information is go up and then come down, go up and come down, ऊपर जा फिर नीचे आ, go up and come down till it reaches this point, which is a rigid body, 100% rigid body. Okay. There cannot be a refraction. No part of this energy can go there. And the rigid body is rigid. The rigid body is very strong. And the rigid body tells the string, what did you say? Go up and come down. Nonsense. Go down and come up. I give you the instruction. So the instructions that were followed, that instructions have been reversed. And upon reflection, there is a phase change of pi radians, and it goes back like this. Okay, it's shown that maybe I should have made it like this. There is no loss of energy whatsoever. Whatever is coming here, and the instructions were coming, the data were coming, the data were reversed, and it went like this. Okay. Go up and come down. Nonsense. Go down and come up. Okay. And what can the poor fellow do? The poor fellow has to follow. Okay. The rigid ones. And everything is happening according to the Newton's laws of classical mechanics. Well, what I can say is, let us mathematically say that the incident wave, now we are going for wave propagation rather than a pulse propagation. Incident wave is yx comma t is equal to a sine of omega t kx minus omega t. Upon reflection, because there is a phase change of pi radians, so this pi radians is added to it. And what it means, if there is a phase reversal by pi radians, then you can see that the nib is on this side, and now it becomes like this. So there is a complete opposition, completely out of phase. And y1x comma t, the reflected wave, will become equal to a sine of omega t, kx minus omega t plus pi. By the way, you can take cos, no problem. Okay. So it will always be reversed. And therefore I can write anything which has, it is represented by this negative sign. And so I have one equation like this and the other equation like this. Okay, minus a sine of omega t, kx minus omega t. Okay. At the open boundary, now let us talk about another situation, that the string is under tension. Okay, but this string is attached to a rod, which is a rigid rod, and a ring is attached over here. There is a ring around it, and the string is attached to the ring. Now the ring is free to go up and come down, go up and come down, as per whatever instructions are coming. Go up and come down, ring. So now in this case, if the incident pulse is coming like this with the instruction go up, come down, go up, come down, go up, come down, and here it can just give the instruction to the ring, go up, come down, and what happens? That after this reflection, there is no loss of energy whatsoever, because this is the sliding of the ring in the rod, which is cylindrical, of course, it is smooth. Of course, we will consider this to be massless. I will consider this to be ideal. With all those situations, ifs and buts, what happens is that the ring is a freely moving ring. Can go up, come down, upar ja, niche a. So it follows the instructions, and now the reflected ray, you can see that the reflected ray is also go up, come down, go up, come down, go up, come down, upar ja, niche a, upar ja, niche a. So the delta phi in this case is equal to 0. Okay? An example is a what we call an open end of an organ pipe. The organ pipe is there, this end is open, this end is closed. It can be open on both sides. Okay, the pipes are examples where we can have both ends as open ends and there is a freedom, etc., etc. Okay. Now this case, at the open boundary, this equation, this can be written as A sine of omega t A sine of kx minus omega t plus 0, which is the phase which is there. Naturally, if it's 0, then it will turn out to be equal to A sine of omega t plus A sine of kx minus omega t, and we obtain this kind of a behavior for the waves. So the waves that come this side and the waves which go back, they are in the same phase. Okay. So this is another discussion. At the rigid boundary, however, in this case, y will be equal to y1 plus y2. Okay? And y1 plus y2. One going one way and the other is going the other way. Okay? Upar ja niche ja upar a. And therefore they will cancel out each other always. And the value of the y, the disturbance at the rigid boundary, shall be equal to 0. We will find that the amplitude is equal to 0, whatever, and that is what is happening. Now, I just to discuss with you, I take a stretched string consisting of two parts, and here there is an interface. You can see that this is linear thing and this is okay. The area of cross section over here is another one. Of course, the material will take as the same. For the sake of easy understanding, and in this part of the string and this part of the string we have a tension. Unless there is a tension, there will not be any transport of energy from one side to the other side. Now what happens? At this boundary, here the value of mu, that is mu2, is more than the value of mu1, and therefore the velocity here is more than the velocity over here. Okay? So what happens? Here at this end, although it is going straight, there will be something, and two things will take place. Rarer to denser, it behaves as if it were a kind of a rigid body over here, and so This is the action for the pulse. Upar ja, niche a. Go up, come down. Till that place. And here, this fat one will say, no. Niche ja, upar a. Go down, come up. But part of this pulse will be refracted into the denser medium. Naturally, I have shown that its energy has come down, okay, its amplitude has also come down, and it has travelled less in the same amount of time, because V2 is a denser medium for this case. So this side is, I again tell you, look here, this is what is going to happen. From here to here rarer medium, here to here denser medium. So what will happen? That you have the instructions, you have the data, you have the transfer of information, and that is go up, come down. Okay? This reaches up to this point. At this point, the denser medium says, oh, you have come there, welcome, welcome, no problem. But if you want to go back, then go down, come up. Niche jaakar upar aa. And here, it will say, okay, okay, come. So it happens like this, and it travels up to this point. Now what happens? Here there is a rigid body. I have just shown to you, this is a rigid body. This is the same situation like here. So what will happen? That there will be a reflection. And the reflection I will show without losses, and this is the reflected wave over here that will travel back over here. But what happens? You can ask me. What happens when it is coming back, the red one, okay, and it is now encountering the interface denser to rare. So the rarer one will behave like the free moving ring and will say, okay, please come, there is no problem. Okay, and the reflection over here, there will be a transmission. The transmission will be like same, but the reflection, of course, whatever reflection is taking place over here, that may come back like this. Well, the reflection and refraction, they act according to the Snell's laws of reflection and refraction. Okay. Right now, in this class 11th India, there is no occasion for that. But if I were teaching you optics, then I could have taken these things in further detail. I have shown it for stretched strings, but the same physics, the same set of arguments, everything will be there for the gaseous medium and for the energy transfer by means of longitudinal waves. Okay.